Hello, everybody. My name is Sylvain Rochon, as always, and I'm still writing. I'm writing my book, my second book, Engineering Paradise. I'm almost done, actually. Today I'm going to talk about the end of the economy section, and then moving on to the final section, which is just a bit of a conclusion section. But that's going to be in the next video, and probably a couple more, since I want to wrap up a few things. But this particular video is about decentralized ledgers, otherwise known as blockchain. Some people just call them Bitcoin, which is quite inaccurate because that's a brand. That's one, blockchain, one technology that's out there. In fact, there is now, I believe Bitcoin became somewhat popular in niche areas in 2009, and it was a name that kind of floated around as a decentralized cryptocurrency. You all would probably heard that word. And some people have started businesses around it. Some people were accepting it. It started transferring hands. But ultimately, what I want to talk about is decentralized ledgers. And the reason being is that's a concept. There's over 1,000 different cryptocurrencies and different types of digital products that exist nowadays that are based on the blockchain, on the Bitcoin concept. This is all programming. This is code. It's basically a new way to interact with individuals using software that avoids centralized system. That's why it's decentralized, and it's a ledger system, because you see transactions like you did this, I did this, and these can be units of money, like a Bitcoin, or they could be terms of a contract. It's gone beyond cryptocurrency. Basically, it's a ledger system that is completely decentralized. So you don't need a centralized entity to manage it. It kind of floats on its own in the cloud, and it lives there under certain rules that it was coded under. And what's exciting about this is that it can be used for so many different things, and it is superior to traditional ways of interacting with other individuals digitally. Because essentially it's superior in many ways to how we've been doing things so far. Because so far we've been, like, for example, you have a company, it could be IBM, a bank, or whoever, creates a certain software, pushes it out, it controls the software, everything that's under the hood. It can make modifications and can pick out information. It has to control the information of the different accounts that are on there, whether it's money transactions. There's all this legal system around it to keep it secure, because there's a lot of people that are and organizations that are nefarious, that are trying to make money off of it, that are trying to cheat or cause grief and things like that. So it became a huge software industry over the past 50 years or so. With decentralized ledgers, this type of software, it's still software, but it's designed in a way to alleviate a lot of the issues we're having with the traditional systems. So again, there's 1,000 of them. There's more than that, and there's more emerging all the time. And the ideas around the development of these decentralized ledgers are becoming more and more complex. We're getting into different generations of it, where we can do more things, and people are mashing them together and creating cryptocurrency stock exchanges, which already exist since this year or the end of last year, 2017. Just finding, using that type of programming methodology or protocols to resolve some of the modern issues of software, I'd say, and networking, but also to resolve new issues that we couldn't efficiently deal with the old way of doing things. So just to give you guys an idea of what a decentralized ledger's characteristics are, there's 4 general characteristics, and these can be, because it's software, these can be adapted and done in many different ways. But these are the 4 criteria of decentralized ledgers. Now, first off, they are very secure. They are encrypted in such a way, in bank level cryptology. Anyway, we can do that. So there's a level of encryption to make it tamper-proof. And part of its tamper-proofiness is that it is distributed also. So it's not the information on these ledgers are not localized in a single server. They are actually fragmented or copied, depending on the protocol, on a network of different computers and hard drives, which are not typically company owned. They are on your smartphones, on your PCs, on your laptops, and everywhere throughout the whole population in such a way that it's hard to tamper with. And the cryptocurrency that is the cryptology is used on a single devices make it extremely, almost impossible to hack into, to read information. Although that is still possible, just like it's possible, to break into NORAD or a bank, a computer. It's extremely difficult to do that, and all you can do is really read, and that because of this. The second characteristic is because it's shared data. Again, it's on the network. So if you want to make any kind of modification to it, you have to actually modify the majority of the network. So if you have 1 million computers, that means 1 million people are using, let's say, Bitcoin or another cryptocurrency or an Ethereum token base or whatever it is. Then you have to be able to hack simultaneously, almost simultaneously, half of those devices, or 500,000 devices simultaneously. And they're connected with each other without a central way of connecting with each other. It's currently impossible to do. So it makes it secure. Now, the fact that it is shared data also makes it very trustworthy, because even the originator, unless they created a backdoor, like this is the creator of the software, like not all Bitcoin or cryptocurrencies or decentralized ledgers are the same. They're all developed by people that have different intentions, right? Unless they create a backdoor to modify everything everywhere in some way, which is possible to do, then even the creators, like the programmers, can't modify the data that is located on there, because you'd have to modify the whole bunch, or at least half of them, or a whole lot of them, and you can't, because it's all sorts of devices, operating systems everywhere. Also, it has authentication, which means it usually has like some public and private keys. Which is a private key is a public code that you would have, like as a user, so that you can access your transactions, your information easily, because otherwise you wouldn't be able to do that. And it goes through the cryptography and allows you to read your own things that you have business to be able to read, basically, right? And it has also a public key that you don't know, so that you can't cheat and look at other things. But you need both. You need to have access to the system, which is the public key's purpose. And you have your own private key that allows you to read your own things. You need both. And so it's you can read, you can write to it, so you can add information to it, just like when somebody does a Bitcoin transaction on this decentralized open ledger, then you're adding an element to the ledger, and the other person agrees, which has also an identity, and then the transaction happens. The information from the ledger is distributed throughout the network, so 2 million people receive that transaction. Unless both people agree that they want to change that transaction through using their identity keys, it's over, it's done. So you can't really cheat, and it's transparent, which leads you to the fourth point, which is the auditability. Because people can't change it, and it's all written out, and everybody has copies, basically, of the information, even though they can't read it themselves, unless you have the key. then you can create an audit. It has a very clear audit trail. You can't cheat it. So if, for example, if you have a national decentralized ledger handling the economy, for example, which is what I am indeed suggesting, I'll get to it in a minute, then you can essentially, with permission from regulators, or from the lawmakers, or security services, or whatever, then you can audit whatever you want to find if there is illegal activity, to figure out missing bits and pieces of assets, whatever it is you need. And you can't, even that organization, it can read, it can audit it, can't modify it. You can just figure out if what others have been doing nefariously or not, right? With permission, and that's all about the legislation part of it. So that they're handed over, they can ask for the keys. So it's like you know, a subpoena, or you know, it's like, okay, we need to audit this, so we need your information. We use it for this, and then after the investigation is over, perhaps you can change your keys and things like that, so that we can't go over and be nasty with you, because these are still people. So it creates a lot of transparency. It creates a lot of trust in the system, because there's no centralized, potentially no centralized organization that actually controls it. The government, agencies, individuals, banks don't need to touch it, because it's directly from person to person, from entity to entity. The transactions happen. It's directly on the network, on the internet. So people can just do their transactions on their own. And it's all in the ledger. It's all kept for posterity, for history's sake, and you can backtrack, audit it, all that stuff. It's very, very cool technologies that we can use as a platform to do a lot of different things, including a national decentralized ledger to handle the national economy. I've been talking about the economy for a while, and also this online system where we can use direct democracy. So essentially the population telling the ministries, telling the governance systems what their wants, what their needs are, what they feel, and all that stuff. That is all information that can be kept on decentralized ledgers, so that it can be tampered, it's clear, it's auditable, it's transparent, it's trusted, so people can feel confident about the information that's circulating, and the accesses and all that stuff. Really important, because we're dealing with a population, in our case, with this ideal world, that actually owns all the land. It owns the properties collectively. So you need to have trust in a system, in a technology that allows this communication of how assets are distributed, allotted, the terms of the different contracts, all this stuff needs to be reviewable, as well as the online system I keep talking about. With these communications going on, you need to be able to check if, using AI as support, because there would be huge amounts of information, like, is the government system really listening to the population? Are they really doing their job? You can audit it yourself if it's built to allow that, because it's code, it's software, it's not rigid. You can make it the way you want to make it fair, so that the population has control over everything. Now, about another example of work compensation, we talked about basic income. Well, this decentralized ledger, again, is transparent. That can be used to propagate cryptocurrency, so that people can receive their basic income and also use it for all their trades and transactions, to spend that basic income, the units they would receive for services rendered. You know, I can provide you with a piece of art. Somebody on the market wants to buy it. Well, that's information on the ledger. Units transferred from one person to another. So I receive better units. I have more units than the other, because I contributed to society something that is wanted or desired. I get paid, and then I can spend that money on something else that I want, that somebody else has produced, or a company, or whoever, right? So it's just really putting what we know as our system of transactions today on an extremely safe, trusted, secure system that we can trust. And you know, the identity keys that I mentioned for identification on these ledgers, you don't need to use alphanumeric codes or passwords, which is what is still common today. We already can use biometrics like facial recognition. AI can recognize my face. I'm doing a transaction. It looks at my body, looks at my eyes, looks at my face. It knows it's me. And just in case it could be somebody that had cosmetic surgery, you could also use other biometrics like fingerprints, retina scan, whatever else if we want to layer on more security, just to make sure this individual is exactly the same individual that is allowed. So you don't need to remember passwords and anything. The AI would look into all the biometrics that this person, his behavior, his voice patterns, whatever we need, is the exact person that that is allowed these permissions on the ledger, and so that owns certain things, whatever, right? So we can do all that, and then we have an economy that kind of runs itself on the web using artificial intelligent agents. Agents are small softwares that are attached to bigger software that do different intelligent things. And we don't need the banks. Don't need a whole bunch of organizations to manage it, because it's managed on the internet directly and by us, by the population. And so we just get to use that system to keep things fair and to allow us to just focus on what we want to do, which is doing things, feeling things, enjoying life. And that's it. All right. Anyway, that's going to be it for this chapter. This has been very cool doing the economy, because the economy is at the forefront of a lot of people's worries about the future. And hopefully that has been illuminating, and we can build something like that in our near future. Ciao for now.